So let's get into probably the most important graphic for statistics, which happens to be the histogram. Okay, so here lots of different kinds of histogram. Maybe we'll try a few of these things to see what happens. So let's just first start with a simple histogram. Here I'm just going to do a histogram of column 11. I've called it the histogram beta. I could do a histogram on these dot plot columns as well, but we'll see. First of all, let's go into options here, or to scale. Scale, yeah. So here, there are some things that you could do, but the important tab here is the Y scale type. So here you've got three different scales that we are going to talk about here. So the frequency scale, this is just the number of times something in a particular bin happens. So the frequency is another name for count. So here you can see just quickly 1, 2, 3. There are 3 0.5s. Okay, so the frequency of 0.5 is 3. I could also do a percentage, or also called a relative frequency. I don't know how many data points I have. Let's say 100. If 3 of them are 0.5, then I've got 3% being 0.5. And a density, which we'll discuss a little bit later, but basically the density histogram gives you the area of a particular representation. So, I mean, it doesn't really matter which one you put. Let's try a frequency for now. Under labels, again, I like to use the Y value as labels. Makes things more clear. And let's just see what we get. Okay, so because I put labels, I get these little numbers on top. There are 19. What is the frequency? Well, in between here and here, which is hard to tell because they're not labeled, but the data in between this value, let me just hover and see what I get here. So in between 0.4 and 1.2, so in between the values 0.4 and 1.2, there are 19 data points in between the value 0.4 and 1.2. There are 7 data points in between 1.2 and 2.0. Okay, and so forth. Minitab just did this for us without asking for anything. Some particular issues I don't personally like. You can see how this value is being placed in the center. Makes it sort of hard to understand what's going on. So here, if we want a little bit more customization, what we should do is click. Okay, so I just clicked while I was on some of the rectangles, and you can see these little corners come up on each of the rectangles. When that is the case, then I can now double click, and I get some more options for editing. Okay, so here I can mess around with the binning. Okay, the binning is telling you how wide and specifically what's going on. So some particular features, the interval type. So midpoint or cut point. So if I go to cut point, which I personally like a lot better, let's see what happens. Here, instead of getting values in the center of bars, you get the values on the ends. Okay, so here it's much more clear to see that this bin now is in between 0 and 0.8. So this value here, they don't label it, but it's 0.8. So how many data points are in between 0 and 0.8? Apparently there are 14. However, maybe this is not what you wanted still. So when these little corners appear on the rectangles, I can double click on the columns. I can change things further. Okay, so how do I want to define here my particular regions? Okay, so cut point I like better personally. Number of intervals. Well, here you can adjust the number of intervals. Currently there are 10 rectangles. Let's say we want 20. Okay, this is going to give me 20 equally sized rectangles, as you can see. Okay, so these are narrow bins. When you have narrower bins, you see that you get more and more close to what would be like a dot plot. Okay, so you can see the different groups that are sort of emerging here. Okay, that's fine, but you know, when your bins get more and more narrow, you start to lose overall information. Okay, so you don't want to necessarily have a bin that's too narrow. You don't want to have only 3 bins. This would be too wide. You just get very, very summarized data. Okay, what we want to do is actually understand the shape of the data. Okay, so we want to understand the shape of the data. You know, we can click automatic to see what Minitab does for us. you can see the overall general shape. You pretend you're sort of shape cutting around this, and you get this increasing. Actually, this is called right skew. I know it's right skew because I go to the tallest bar, which happens to be the first one in this particular case, and then I draw a little arrow here to the tail. So from the middle of the tallest bar, this is the arrow, and then from the middle of the tallest bar, this arrow goes all the way to here. So which side going from the tallest is longer? I can see it's the right side that's longer. This is called right skew. Okay, you can further customize any sort of bins that you want. Okay, so here, if I want to tell Minitab where exactly I want the bins to be, I can say, I want to bin in between 0 and, I don't know, 0.1. So I'm just separating these with a space. And then 0.1 to 0.2. And then 0.2 to 0.4. Then here, from 0.4, I want to have till 9. Okay, so that's a little bit strange, but let's try it. Okay, so here I've got all these little bins, and then I've got this huge bin from 0.4 to 9. Okay, so this is kind of crazy. It's not really a good choice. Maybe I got a little over anxious here. So maybe let's just continue by 0.1. Here it says the bins need to encompass all the data. So what does that mean? It means that I didn't, I stopped at 0.7 and some of my data was a lot larger than that. So what it did was automatically just went up by 0.1 for me and then put that in there. As you can see, this is a very, very narrow binning. However, I can get whatever bin I want to get this way. Okay, so I can actually fully customize how I want the histogram to look. Okay, so one other thing that I want to show you is, often, let me just see if there's any data here that makes any sense. Okay, when I'm doing something like a grade category, where you've got percentages, so here let me just make up some data for a second. Okay, so here I'll just put some potential grades. Okay, and then maybe I've got what are the letter grades? You could have an F, you could have a D, you could have a C minus, you could have a C, you could have a C plus, you could have a B minus, you could have a B, you could have a B plus, you could have an A minus, you could have an A, you could have an A plus. Okay, and what are the actual cutoffs? Okay, so this is just letter grades. So these are the names. Where are the actual cutoffs here? Well, we'll do this. So let's try and see if I could make a mock histogram be what I want it to be here. So graph, histogram. Here I want to do a histogram of this data I just made up called grades. Okay, and under the labels, I want to use these labels from this column that I just made, column 19. Okay, so C19. Okay, so originally this doesn't necessarily make sense just yet. I'm going to further customize things. I'm going to do cut point instead of midpoint, and then I'm going to tell Minitab where my letter grade breakdowns are. So from 0 to 50% is an F. Then every 5% something happens. Okay, so a new letter grade happens at every 5%. So let me just put this in here. Okay, so what happens? Okay, so here you can see how many A pluses, how many A's, how many A minuses, how many B pluses, and so forth. Okay, so one thing that I do want to discuss here is that here the number of F's that I have is really just 2. There are only 2 F's, and but the F's look like they're overinflated here. I mean, everything else is 1. There are 2 F's. It looks gigantic. The reason for that is because there's way more possibilities of how to get an F. Anywhere from 0 to a 50 is an F. Okay, everything else is only 5%. So, often F will look overinflated. When you have bins that are not all the same width as each other. So here I've got all of these bins are just 5% increases. However, this guy is a 50%. When you have that, instead of doing the frequency, which just counts how many there are, and instead of doing relative frequency, which just gives you the percentage, what you could do, maybe what you should do, is the best idea is instead of doing a frequency or a percentage histogram, that's when it's a good idea to do a density histogram. Okay, so when is it a good idea to do it? So let me sum up because this is important. When is it a good idea to do a density histogram? When your bins are not of equal width. Okay, so let's try this. Okay, so here, again, let me put in the bins. It's 0 and 0.5 and 0.55 and 0.6. Sorry, I guess I wanted to see if it would fill it in for me. It won't, so I'll just put it in. Okay. Midpoints, oh, sorry, it says midpoints have to be of equal length. I don't want midpoints, I want cut points. Let me just copy and paste. Sorry, cut points. There we go. Okay, now this area represents the actual amount of value going on here. And you can see that because F is split up, it's not an equal size as all of these other sizes are, then we don't really want to overinflate how much F is. So here, instead, the amount of data that is being included is not represented by the height of these things any longer. It's being represented by the area. Area is base times width, so it's 0.5 times by the height, which you can see here is, what is the height? It's also 0.5. So 0.5 times by 0.5, then there is 0.25 amount of our data. A quarter of our data is Fs. Okay, so that's the other way to do this. So that's a little bit about histograms.